Hey, Rob here, and I'm going to show you my spring break project. So we had some problems with the Nav algorithm, and I set out to build a little more robust, more technically properly done project. And so the way I did that is shown in this screen here. So in the top left, we convert our originally acquired color image to a grayscale image. We then pass it through a canny edge detector, which is shown here, and we can see that pulls out a pretty well-defined edge detection of the SIP that I've slightly modified by adding white tape around the edges to give us that really well-defined edge to pick up with that canny edge detector. Once we've done that, we run that through a rectangle detection algorithm. After passing it through the rectangle detection algorithm, that's where we pass it through a couple of filters that I've put together in LabVIEW for us. So the first filter looks at the standard deviation of all three color channels, red, green, and blue, within all of the rectangles that we found. If those standard deviations are above a set threshold value, about 60 in the intensity in any channel, then we immediately discard that. And what that does is it takes advantage of the assumption that our SIPs are all a uniform homogeneous color, and so it finds if a rectangle that we found is not a homogeneous color, then we immediately discard that as noise. And that's really effective at discarding some of the random rectangles we'll find in the background or any chairs or other things that are in the field of view. The second filter that we pass it through filters it based on the relative comparison of the color that we're looking at to some predefined constants for all of the 5 colors that we're looking at on the SIP: red, green, blue, pink, and yellow. And so it finds the mean intensities of each of the 3 channels again, red, green, and blue, and compares those values to those set values. Whichever one it's closest to, that's most likely the color that we're looking at. Again, if the deviation in the average color that we found and the constant colors that we predefined is too high, again, I was using around 60 or 80 for our threshold there, then we discard that again as being a uniform section, but not of one of the colors that we'd like. And so this is something that has been really effective in determining rectangular regions in our field of view that are our SIP because of the color rejection and the uniformity in the color rejection as well. Where this breaks, though, is that it's relying on the assumption that we're looking at a rectangle, because that's the only shape detection block that we immediately had access to in LabVIEW. So you can see when the child is on the down slant and the plane of the SIP is approximately perpendicular to our camera angle, it's looking at a square and it can find it really well. However, when the child is down on the floor and it's rotated even slightly, it's no longer a rectangle, it's now a parallelogram, and that same algorithm won't find our SIP anymore. And so that's where my algorithm breaks, and that's why we're not immediately choosing to go with it.